Hello everyone. In this video, we will learn how to solve the given system of linear equations. There are different methods to solve the given system of linear equations. In this video, we will learn about how to solve the given equations using Cramer's rule. Solve the following system of equations using Cramer's rule. We will be given three equations. Together these three equations is called as a system of equations. So first we need to write the coefficient matrix. So let us write down the coefficient matrix. Let A equals to coefficients of x, y and z. In the first equation the coefficients are 1, 1, 1. Second equation the coefficients of x, y, z are 2, 2 and 3. In the third equation, the coefficients of x, y, z are 1, 4 and 9. Then the variable matrix, we denote it as capital X. There are three variables involved in the equations, x, y and z. And the constants, we can write either capital D or capital B. So these are your constants. So this is called as the constant matrix. First, in Cramer's rule, we need to find the determinant of the matrix A, the coefficient matrix that is. So determinant of A is denoted by the symbol delta by in Cramer's rule. Delta is nothing but determinant of A. So let us first find the determinant of A. Let us write down the elements of A in the determinant form. We use a mod, under mod kind of thing, that is under mod is the determinant of any matrix. So we know how to find the determinant already in the previous videos. I have explained you how to find the determinant. The first thing is we expand the determinant either along first row or second row or third row or first column or second column or third column. Most of the time we will be expanding the determinant along the first row. So the first element is 1. You leave out the row and column where 1 is. You just leave out the row and column where this first element 1 is. So for example, this is your element, so we will eliminate this row and this column where this 1 is present. Then the rest of the elements we can write in the determinant form 2, 3, 4, 9. This is your first element. So 1 into the remaining, we have left out the first row and first column, remaining 4 elements. Second element always will have minus sign. This is by default, and the element here is 1. So you need to leave out the row and column where this 1 is present. So the first row and the second column we have to leave out, and then the element is, remember, 1 into the remaining 4 elements after eliminating the row and column where this 1 is present. It is 2, 3, 1, 9. The last element again will have plus sign. So plus, the element here is 1. So we have to leave out the row and column where this 1 is present. That is the first row, and the third column we need to eliminate. The rest of the 4 elements we have to write in the determinant form 2, 2, 1, 4. So this is how we expand the determinant of a 3 by 3 matrix. First element will have positive sign, second element by default will have negative sign. Whatever may be the sign of the number which is in the second place here, irrespective of this sign of this number, this will be by default negative sign. So leave out the second column and first row, the remaining 4 elements. Then the last element again will have plus sign, whatever may be the sign of the number there. Leave out the first row and third column, the remaining 4 elements in the determinant form. So we have expanded the determinant along the first row. Now each of this determinant is in the form of A, B, C, D. Remember, the determinant of A, B, C, D is nothing but AD minus BC. It is first element into last element minus second element into third element. So each of this determinant should be expanded using AD minus BC form. So the number here is 1, AD minus BC, 2 into 9 is 18, minus 3 into 4 is 12, minus 1 into again AD minus BC form, 2 into 9 is 18, minus 1 into 3 is 3, plus 1 into again AD minus BC form, 2 into 4 is 8, minus 2 into 1 is 2. So 1 into 18 minus 12 is 6, 18 minus 3 is 15, plus 1 into 8 minus 2 is 6. 1 into 6 is 6, minus 1 into 15 is minus 15, plus 1 into 6 is 6. So 6 plus 6 is 12, 12 minus 15 is equals to minus 3. So determinant is minus 3. So determinant is equals to minus 3. That means this is not equals to 0. Once we get the determinant is not equals to 0, we can solve the given system of equations by using Cramer's rule. If the determinant is 0, we can say that we cannot solve the given system of equations using the Cramer's rule. So here we have got the determinant value, that is the delta value as minus 3, which is not equals to 0. Hence we can solve the given system of equations using Cramer's rule. So since the determinant is not equals to 0, we can solve the given system of equations by Cramer's rule. Now according to Cramer's rule, we need to find 3 more determinants. One is delta 1. Delta 1 can be obtained by... So delta 1 is obtained by replacing the first column in matrix A with the constant terms. So you have matrix A, the coefficient matrix. You replace the first column in your matrix A with the constants. The other two columns will be same as they are in the matrix A. So this determinant will give you the value of delta 1. So first element is 1, devote the row and column where 1 is present. The remaining 4 elements you need to write in the form of determinant. Second element always will be minus sign, which is by default formula sign minus. The element is 1. Leave out the second column and the first row and the second column. The remaining 4 elements you have to write in the matrix form, determinant form. 6, 3, 3 9, plus the last element is 1. Leave out the row and column, the first row and the last column where this 1 is present. The remaining 4 elements in determinant form. Again, the determinant of ABCD is in the form of AD minus BC. So 2 into 9, 18, minus 3 into 4 is 12. Same way you have to write 6 into 9 is 54. Minus 3 into 3 is 9, plus 1 into AD minus BC, 6 into 4, 24, minus 2 into 3 is 6. So this is 1 into 18 minus 12 is 6, 54 minus 9 is 45, 24 minus 9 is 18. So 6 minus 45 plus 18 is equals to minus 21. So 24 minus 45 is minus 21. Similarly, you need to find the determinant delta 2. Delta 2 in your matrix A, you replace the second column with constants. The other two columns will be same as they are in your matrix A. So the second column is replaced with the constants and the other two columns are same as they are in matrix A. So again let us expand. The first element is 1, leave out the first row and first column. Remaining 4 elements 6, 3, 3, 9. Second element again will be having minus sign. The element is 1. Leave out the first row and second column. The remaining 4 elements are 2, 3, 1, 9 plus the last element. Leave out the first row and the last column. Remaining 4 elements are 2, 6, 1, 3. So again AD minus BC form, 6 into 9 is 54. minus 3 into 3 is 9. So everywhere you have to use AD minus BC form. 2 into 9 is 18, minus 3 into 1 is 3. 2 into 3 is 6, minus 1 into 6 is 6. So 54 minus 9 is 45, 45 into 1 is 45. 1 into 15, 18 minus 3 is 15, into minus 1 is minus 15. So 45 minus 15 is equals to plus 30. Same way we need to find one more determinant, and that determinant is delta 3. So delta 3 is obtained by replacing the last column of your matrix A with a constant. The first and second column will be the same as they are in matrix A, and the last column, the third column, is replaced with the constants. So let us expand this. 1 into the first element is 1, leave out the first row and first column. The remaining 4 elements, again minus, second element is 1, leave out the first row and second column. We have 4 elements in the determinant form, and the last element is 1, leave out the first row and the third column, remaining 4 elements. So again, all the elements determinants are in the form of ABCD. So determinant of ABCD we know is AD minus BC. 2 into 3 6, minus 6 into 4 is 24, minus 1 into 2 into 3 is 6, minus 1 into 6 is 6, plus 1 into 2 into 4 is 8, minus 2 into 1 is 2. So 1 into minus 18, minus 1 into 6 minus 6, 0, 8 minus 2 is 6. So minus 18 plus 6, second term becomes 0. So minus 18 plus 6 is minus 12. Okay. So we have got all the three determinants now, delta 1, delta 2 and delta 3. Hence by Cramer's rule, we can find the values of x, y and z. Hence by Cramer's rule, we can write x is equals to delta 1 by delta. Delta 1 we got is minus 21. Remember delta we got as minus 3. So minus minus cancel. 3 goes 7 times. Y is equals to delta 2 by delta. Delta 2 is 30 by minus 3. So 3 into 10, 30, minus sign is remaining there. Z is delta 3 by delta, which is minus 12 by minus 3. Minus minus cancels. 12 by 3 is 4. Therefore, x equals to 7, y equals to minus 10, z equals to 4 is the solution of the given system of equations. Okay, is the solution of the given system of equations. So x equals to 7, y equals to minus 10 and z equals to 4 is the solution of this set of equations. If you want to verify whether your values of x, y and z are right or wrong, you can use any one equation. You have three equations, given equations. There are three given equations. You use these values of x, y, z in any one equation. If it satisfies, that means your values are absolutely right. Solve the following system of equations using Cramer's rule. Our system of equations are 2x minus y plus 3z equals to 9, x plus y plus z equals to 6, x minus y plus z equals to 2. So these three equations put together is called as a system of equations. We have to solve this system of equations using Cramer's rule. That means we have to find the values of x, y and z. First of all, we need to write the matrices here. First we write the coefficient matrix, coefficients of the variables x, y, z. The first equation, the coefficient of x is 2, coefficient of y is minus 1, coefficient of z is 3. The second equation, the coefficients are 1, 1, 1, 1x, 1y, 1z. The third equation, coefficients are 1, minus 1 and plus 1. Then we write the variable matrix X as X, Y, Z, three variables, and D is the constant matrix. Our constants are 9, 6 and 2. So first of all, in Cramer's rule, we need to find the value of determinant of A. Determinant of A is denoted by delta. So we need to find the determinant of the matrix 2, minus 1, 3, 1, 1, 1, 1, minus 1, 1. So the first row is 2. The first row is 2 minus 1, 3. We expand the determinant mostly along the first row. We can expand along any row or any column. We always prefer to expand the determinant along the first row. So the first element is 2. So we need to write the first element 2. Leave out the row and column where we have the 2. The rest of the 4 elements we need to write in determinant form. Okay. First element is 2, leave out the row and column where 2 is present. The remaining 4 elements in the form of determinant has to be written. The next element sign will be minus. The element is minus 1. So we need to, this is minus sign by default. When we're expanding the determinant, we start with plus, minus and plus. There are 3 elements in the first row. First element will have plus sign, second element will have minus sign, third element will have plus sign. So irrespective of whatever is the sign of the second value, second number here, this is by default minus. Our number is minus 1. So this is what is our element now. We need to leave out the row and column where this minus 1 is present. The remaining 4 elements we need to write in the form of the determinant. Okay. Then the third element will have plus sign. The element is 3. Leave out the row and column where 3 is present. The remaining 4 elements should be written in the determinant form 1, 1, 1, minus 1. Now each of these should be is in the form of determinant of A, B, C, D. Each determinant is in the form of A, B, C, D. So we need to write the determinant of A, B, C, D. We know is in the form of, we write in the form of AD minus BC. So 1 into 1 AD minus BC. 1 into minus 1 is minus 1. Then minus of minus 1 is plus 1. Again determinant of ABCD is AD minus BC. 1 into 1 is 1. Same way here again determinant of ABCD is AD. 1 into minus 1 is minus 1. Minus BC. 1 into 1 is 1. So we have 2. 1 minus of minus 1 is 1 plus 1 2. Plus 1 into 1 minus 1 will be 0. 3 into minus 1 will be minus 2. So 2 into 2 is 4 plus 1 into 0. 3 into minus 2 is minus 6. 4 minus 6 is minus 2. So whether it is positive or negative, but what we have to look at it whether it is 0 or not equals to 0. So once the determinant of matrix A, that is the value of delta, is 0, we can say that we can solve the given system of equations by using Cramer's rule. Hence, we can solve the given system of equations by Cramer's rule once we confirm that the value of determinant of A is not equals to 0. Now, in order to solve this system of equations using Cramer's rule, we need to find 3 more determinants. The first one is delta 1. Delta 1 is obtained by replacing the first column of matrix A with the constants. Remember, we have to concentrate on matrix A. According to matrix A, we need to first eliminate or replace the first column in matrix A with the constant terms. So the first column of matrix A will be replaced with constants. The rest 2 columns will be same as they are in matrix A. So we have replaced the first column from matrix A with the constants. We write it as delta 1. Now we need to expand this. Again we will expand along the first row. The first element is 9. So you have to leave out the row and column where that 9 is present. So the rest elements we need to write in the form of determinant. So the next will be sign will be minus. The next element is minus 1. Now for minus 1 second element, it is in the second column and first row, we need to eliminate the first row and second column. The rest 4 elements we have to write in the form of the determinant of the remaining 4. The last element plus the last element is 3. Leave out the first row and the third column where 3 is present. The remaining 4 elements we have to write in the form of determinant. 6, 1, 2, minus 1 are the remaining 4 elements which we have to write in the form of. Now we will solve this. Each of the determinant is in the form of A, B, C, D. Determinant of A, B, C, D we know is AD minus BC. 1 into minus 1 is minus 1. Minus into minus 1 is plus 1. Again ABCD determinant is AD. 6 into 1 minus BC. 1 into 2 is 2. Plus 3 into AD minus BC. 6 into minus 1 is minus 6. BC 2 into 1 is 2. So 9, 1 minus of minus 1 will become 1 plus 1, 2. 6 minus 2 is 4. 3 into minus 8. So we have 9 into 2, 18 plus 4 minus 24. That is 22 minus 24 is equals to minus 2. Then the second determinant we need to find is delta 2. Delta 2 is nothing but in matrix A we need to replace the second column with the constants. So the first column and the third column will be same as matrix A, and the second column will be replaced with constants. Remember, we have to concentrate on matrix A, coefficient matrix. In the coefficient matrix, you replace the second column with constants, you get delta 2. Now already we have seen how to expand the determinant. Now we can do it quickly. 2 is the first element. Leave out the first row and first column. The remaining 4 elements in the form of the determinant. Minus, as you know, always you will have minus sign. The element here is 9. Leave out the row and column where 9 is present. That is the first row and second column. Remaining 4 elements in the form of the determinant. Plus the last element is 3. Leave out the first row and the last column, that is the third column. Remaining 4 elements in the form of determinant. Now we can write the determinant of ABCD same as AD minus BC. 6 into 1 minus 2 into 1. AD is 1 into 1 minus BC is again 1 into 1 plus 3. AD 1 into 2 is 2 minus BC 6 into 1 is 6. So 2 into 4 minus 9, 1 minus 1 becomes 0. 2 minus 6 is equals to minus 4. So 2 into 4 is 8 plus or minus 0. 3 into minus 4 is minus 12. So 8 minus 12 will be equals to minus 4. Now we need to find the third determinant, that is delta 3. Delta 3, again we need to go back to matrix A. In matrix A we replace the third column with constants. The first and the second column will be same as they are in matrix A. The third column should be replaced with the constants. Now let us expand along the first row. Again the first element is 2. Leave out the first row and the first column. The rest of the 4 elements in determinant form. Minus, as always, second number will have minus sign. The number is minus 1. Leave out the first row and second column now. So we write 1, 6, 1, 2. plus the last element is 9. Leave out the first row and third column, the remaining 4 elements in determinant form. Again we need to do AD minus BC, 1 into 2, minus 6 into minus 1 is minus 6. Minus of minus 1 is plus 1, AD minus BC, plus 9 into again AD minus BC. So 2 into 2 minus of minus 6 is 2 plus 6, that is 8. 2 minus 6 is minus 4. 9 into minus 1 is minus 2. So 2 into 8 is 16. 1 into minus 4 is minus 4. 9 into 2 is minus 18. So 16 minus 22 is equals to minus 6. So we have got all the three determinants now, delta 1, delta 2 and delta 3. Hence we can solve for x, y and z now. So hence by Cramer's rule, hence by Cramer's rule, x is equals to delta 1 by delta. Remember the value of delta 1 we got is minus 2 and delta value, that is determinant of a value, is also equals to minus 2. So we get minus 2 by minus 2 as 1. Y is delta 2 by delta. Delta 2 is minus 4. Delta is determinant of a is minus 2. So minus minus you cancels. 2 ones 2 2s. So the value of y is 2. Z is delta 3 by delta. Delta 3, that is minus 6 by delta, that is determinant of a is minus 2. So minus minus we can eliminate. 6 by 2 will give you 3. So x equals to 1, y equals to 2, z equals to 3 is the solution. In case you want to verify whether your values are right or wrong, you are given three equations. You can use the values of x, y and z in any of the given three equations. See if it satisfies, that means your values are absolutely right. So we need to solve this system of equations using the Cramer's rule. We are given three equations here. Let us first write down the coefficient matrix. Coefficients of the first equation are 1x, 1y, 1z. So coefficients are 1, 1, 1. Second equation is 2x plus 5y plus 7z. So 2, 5 and 7 are the coefficients of second equation. And the coefficients of x, y, z in the third equation are 2, 1 and minus 1. And x, y as always is a variable matrix. These are three equations in three unknowns, x, y, z. And the constant matrix, either you write capital D or capital B. These are your constants. Now according to Cramer's rule, we first need to find the value of determinant of A. Determinant of A is denoted by delta in the Cramer's rule. So we need to find the determinant of A first. If the determinant is not equals to 0, then only we can solve the equations by Cramer's rule. So we need to first check what is the determinant of A, what is the value of determinant of A. So let's find the first element. Remember, will be plus, minus, plus. So first element is 1 here. You need to write 1, leave out the row and column where 1 is present. The remaining 4 elements in the form of determinant 5, 7, 1, minus 1. Then the next element is 1. So next element is 1. We need to write 1. This is the second element we're talking about. Leave out the row and column where that 1 is present. The remaining 4 elements in the form of determinant 2, 7, 2, minus 1. And the last element is 1. So leave out the row and column where that 1 is present. This is the element 1. Leave out the row and column where that element 1 is present. The remaining 4 elements we need to write in the form of determinant. Now we need to add all these 3 and then simplify and find the value of the determinant. So determinant is in the form of ABCD. We know the determinant of ABCD is AD minus BC. 5 into minus 1 is minus 5. Minus BC, 7 into 1 is 7. Minus 1 into again AD. 2 into minus 1 is minus 2. Minus BC, 2 into 7 is 14. Plus 1 into again AD. 2 into 1 is 2. Minus BC, 5 into 2 is 10. So 1 into minus 5 minus 7 is minus 12. Minus 2 minus 14 is minus 16. 2 minus 10 is minus 8. So 1 into minus 12 is minus 12. Minus 1 into minus 16 is plus 16. 1 into minus 8 is minus 8. So we have 16 minus 2 minus 12 minus 8 is minus 20. 16 minus 20 is equals to minus 4. So minus 4 is not equals to 0. So once the determinant of matrix A is not equals to 0, we can solve the given system of equations by Cramer's rule. So since the determinant of A is not equals to 0, we can solve the given system of equations by Cramer's rule. Now we need to find 3 more determinants, delta 1, delta 2 and delta 3. So delta 1 is nothing but we need to replace the first column in matrix A with constants. The remaining 2 elements, 2 columns will be same as matrix A. So delta 1 in matrix A, you replace the first column with constants. Remember your constants are 9, 52 and 0. The other 2 columns will be same as they are in matrix A. So we are replacing the first column with constants. The remaining 2 columns are same as in matrix A. So we have to concentrate on matrix A. Coefficient matrix, you replace the first column with constants, you get delta 1. So we know how to expand determinant now. So first element is 9. The remaining 4 elements we get by leaving out the first row and first column. The 4 elements we get are 5, 7, 1, minus 1. Second sign always will have minus signs. Second number, the number is 1. So leave out the first row and second column. The first row and second column, the rest 4 elements in the form of determinant. 52, 7, 0, minus 1. The last element again is 1. So leave out the first row and third column. The remaining 4 elements should be written in the form of determinant. Now each determinant is in the form of ABCD, so you can write AD minus BC. 5 into minus 1 is minus 5, minus 1 into 7 is 7. Again AD 52 into minus 1 is minus 52, 0 into 7 is 0. AD minus BC form everywhere. So here again it is 52 into 1 minus 5 into 0. So 9 into minus 12 minus 1 into minus 52 plus 1 into 52. So 12 into 9 is 108 minus 108, and minus into minus is plus 52 plus 1 into 52 is 52. So we have minus 108 plus 104, which is equals to minus 4. Then we will find the second determinant delta 2. So in matrix A, we need to replace the second column with constants. The second column should be replaced in matrix A with constants. The first and the third will be same as in matrix A. Okay, understand very carefully that when you are finding delta 1 in matrix A, you have to replace the first column with constants. When you are finding delta 2 in matrix A, you have to replace the second column with constants and then expand the determinant. So first element is 1, leave out the first row and first column, the remaining 4 elements in the form of determinant. Minus second element is 9, leave out the first row and second column, the remaining 4 elements in the form of determinant, plus the last element is 1, leave out the first row and the third column, remaining 4 elements 2, 52, 2, 0. So wherever that element is present, you have to leave out that row and column. Now AD minus BC again, minus 52 minus 0. AD 2 into minus 1 is minus 2. 2 into 7 is 14. AD minus BC. Again 2 into 0 is 0. Minus 52 into 2 is 104. So we have 1 into minus 52 is minus 52. Minus 9 into minus 2 minus 14 is minus 16. 1 into minus 104 is minus 104. So we have minus 52. Minus into minus will be plus. 16 into 9 is 144 minus 104. So we have minus 156 plus 144. Minus 156 plus 144 is equals to minus 12. So the value of delta 2 is minus 12 now. So the third determinant now, that is delta 3. We need to find delta 3. Remember, in matrix A we have to replace the third column with constants now. The first and the second column will be same as in matrix A. Replace the third column with constants. The constants are 9, 52, 0. So let us expand along first row. Again the first element is 1. Leave out the first row and first column. 5, 52, 1, 0. Minus second element is 1. Remember, by default we'll have this minus sign. Leave out the first row and second column, the remaining 4 elements in determinant form, plus the last element is 9. Leave out the first row and third column, the remaining 4 elements in determinant form. So this is 1 into AD minus BC, again 0 minus 52. AD 5 into 0, BC 52 into 1. Again AD 2 into 0 minus 52 into 2 is 104. Plus 9 into again AD, 2 into 1, 2. BC 5 into 2 is 10. So 1 into minus 52 minus 1 into minus 104, 9 into minus 8. So we have minus 52, minus into minus is plus 104, 9 into 8 is 72, plus into minus is minus. So we have 124 minus 124 plus 104 is equals to minus 20. Hence, by Cramer's rule, we can write x is equals to delta 1 by delta. Delta 1 we got is minus 4. Remember, delta is determinant of A, that is also minus 4. So we have got the value as 1. Y is equals to delta 2 by delta. Delta 2 is minus 12. You can see over here, minus 12 is delta 2 value. By delta is nothing but determinant of A, which is minus 4. Minus minus cancels. 4 1s, 4 3s, we can cancel. 4 3s 12. So y is equals to 3. And z is delta 3 by delta. Delta 3 we got is minus 20 by delta, that is determinant of A is minus 4. Minus minus cancels, 20 by 4 is equals to 5. Therefore, x equals to 1, y equals to 3, z equals to 5 is the solution, the values of x, y and z. In case you want to verify your answer, you can use any one equation. You are given three equations. You can substitute these values in any one equation. If you get the, if you say if the equation satisfies, then you can say that the values are absolutely right.